So we're looking at section 16.1, working on properties of logarithms. So we're going to use our scientific calculator first to find some values of logarithmic expressions. So we'll just do one together and then I'll tell you the values for the rest. So the first one it wants us to do is find log of 10 divided by e. So grab our calculator. We want the log of 10 divided by e. I can raise it. There we go. And we get a value of about 0.566. So you can use your calculator, find these values yourself. 2.303, 4.343, 1.434. And then here in step B, we've got 2.303, 1.434, 0.566, and then 4.343. So you'll notice in set A and set B, some of these values are the same. We want to match those up. So log of 10 divided by e is going to be the same as 1 minus log of e. Natural log of 10 pairs up with 1 over log of e. Log of e to the 10th matches up with 10 log e. And log of 10 times e matches up with 1 plus log of e. So how can we check our results? We can use a circle the wagon. So I just picked one to check with. So we said natural log of 10 is equal to 2.303. So if we think about what natural log is the same thing as log base e. So if we circle the wagon, we're essentially saying that e to the 2.303 is equal to 10. You can check that in your calculator. I think you end up getting something about 10.004, which is pretty darn close. So we say that's good, that's checked. So you probably couldn't tell, but log e and natural log of 10 end up being reciprocals. So we want to think about how we can show that. How do we know that? It's because if you multiply them, it becomes 1. So how do we show that? We'd say that log of e is equal to 1 over natural log of 10, because they're reciprocals, and natural log of 10 then is equal to 1 over log e. So big idea for today is the properties of logarithms. These are super duper important. They're actually very similar to the properties that we had with our exponent rules. So we're mostly going to be working backwards with these. We're going to start off with something that looks like this. And so if we're adding logs with the same base, what we're actually doing is we can multiply the two terms inside of one log. So that's similar before. If we were multiplying with the same base, we added the exponents. So that's what we're thinking of here. If we're adding the logs, we're multiplying the terms. Same idea with the next one. It follows the quotient rule. When we had the exponent rules, if we were dividing in the same base, we subtracted the exponents. So if we're subtracting our logs, we want to divide them. Power rule. When we had a power to a power, we multiplied the exponents. So if we're multiplying a number outside of our log, it's the same thing as raising it to the power inside. Now the last one is super duper important. It's called the change of base rule. What that means is you can use your calculator to solve other bases on logarithms. Before we could only do log base 10 and log base e, but we can use this change of base rule to solve different problems. So for example, if we've got log base 4 of 5, what we can do is take log of 5 and divide it by log of 4, and that's going to give us our value that works. So change of bases here is super duper important. You'll want to use that to solve things in your calculator. This is just a couple properties of logarithms still to keep in mind. So this is working through a proof on the product of properties, product property, but we're just going to mostly apply these. So here we've got log base 3 of 27 minus log base 3 of 81. So again, when we subtract the logs, we want to rewrite it as a division. So we're taking log base 3 of 27 divided by 81. So then what you can do is you get log base 3 of 1/3. We can change that to an exponent. So log base 3 of 3 to the 1, pull that exponent outside. We get log base 3 of 3 is equal to times -1. So anytime you've got a log with the base is the same as the value, it's going to be equal to 1. That was one of the properties I think I skipped talking about, but it's one that works. So if you have the same base and the same value of your log, it's going to be equal to 1. Another thing you could do is just take this from here and do your circle the wagon. So log base 3 of 1/3 is something. So 3 to that something is 1/3, and that's how you can get the -1 answer there. So here we have log base 5 of 1/25 plus log base 5 of 625. So when you're adding logarithms, it can change to a product. We can multiply. So 1/25 times 625 is 25. Now they're having you work it out a little different. At this point, I'd say you can circle the wagon from here. Log base 5 of 25 is something. So 5 to what is equal to 25? That's going to be 2. So that's your solution here. All right, so we want to write this as a single logarithm and simplify then if we can. So the key thing to look for here in this first problem is we've got that 64 to the 3rd power. So if you're raising something to a power, you can pull that 3 outside. So we end up with log base 4 of 64. So 2 ways you can do that. Log base 4 of 64, we can do our circle the wagon. 4 to what power is 64? Or again, we can use that change of base rule at this point. If you're not comfortable with the logs, you can take log of 64 and divide it by log of 4. I'll show you it's going to do that in your calculator. So log of 64 divided by log of 4, and there's telling you your answer is 3. So this is essentially 3 times 3. Or again, if this is an easy one like this one, you can do circle the wagon, go for it. You can find out then 3 times 3 gets you an answer of 9. So number 5 here, we got the same base. We're subtracting our logs. So we want to rewrite it as a division. So it's 18 divided by 2. So we have log base 8 of 9. So this one isn't an easy one to circle the wagon with. 8 to what power is 9? I don't know. So this is where we do want to use the change of base rule. So we're going to take log of 9 divided by log of 8. We're going to plug it into our calculator. Log of 9. Oops, might help if I close my parentheses. Make sure you do that. Divided by log of 8. It's about 1.06. 1.06. And that's the end.